The UltraBeat wrap is a pediatric blood pressure Class II accessory device used to enhance the physician-patient experience during routine checkups. When testing pediatric blood pressure, confusion and irritability of the patient can emerge due to the unfamiliar environment of the clinic. The small size of a child's arteries often leads to repeated attempts by a medical provider to properly position the probe to obtain a reliable measurement. In order to assess the blood pressure in outpatients, medical providers are unable to use a stethoscope in infants because they have lower blood pressure and much smaller arteries compared to adults. Instead, medical providers must use a Doppler ultrasound flow detector on the feet for easy access to the surface blood vessels. The probe of the Doppler ultrasound machine emits a signal that, once reflected off moving red blood cells, will change the pitch of the signal. This frequency change falls in the hearing range of humans. The absence of sound allows the listener to identify that blood is not flowing through the vessel. When conducting procedural blood pressure measurements, one constricts the blood vessel with a blood pressure cuff to stop the blood flow, then releases to allow the blood to flow once more. This turbulence indicates the systolic blood pressure that is read off of the pressure gauge.
The UltraBeat wrap is unique as it is made to fit either foot and align the probe onto either of the main arteries, the dorsalis pedis and posterior tibial arteries used for measuring blood pressure. With 3 main sizing groups, our product is sized to fit children from birth up to 4 years of age. The UltraBeat wrap is made out of marine vinyl, a usable material that can be wiped clean with alcohol, flexible enough to adapt to the foot's contour, and sturdy to withstand daily use. Velcro patches on the product provide an easy attachment and quick removal. The double-sided vinyl wrap is carefully sewn into place with an intricate compartment that can perfectly hold the Partsmed ultrasound flow detector infant probe into place to receive the best signal. When used in tandem with MacLeod brand of ultrasound gel, this creates the most efficient scenario for measuring pediatric blood pressure.
In order to verify that our product works accurately and repeatedly, we developed a model to represent a pediatric foot. In this controlled environment, we were able to create a phantom cast out of Silgard 184 to limit the acoustic impedance of the ultrasound signal with silicone tubing to represent the blood vessels. A blood-mimicking fluid composed of cornstarch, glycerol, and water was developed to best mimic the viscosity and composition of blood. A peristaltic pump was used to drive this blood-mimicking fluid to replicate the blood flow. To verify the FFF model, the acquisition of Doppler ultrasound signals was characterized. Doppler ultrasound signals were captured using the IMEX Pocket Dot2 on a human sample since we did not have access to the Parks Medical Doppler device used at Riley Hospital. The pulse-like sounds heard were buried in noise, therefore the signal had to be filtered to eliminate aliasing, which introduces error in the signal. A TRS patch cable was connected to the IMEX Pocket Dot2's auxiliary port, and the split ends were connected to the input of the analog filter. To visually assess the signal, the output of the filter was displayed on the oscilloscope via a connection established using a BNC to BNC cable. The oscilloscope was configured to display the fast Fourier transform of the input to represent the signal in the frequency domain. The same signal from the filter was used as input to the National Instruments data acquisition tool, which was connected to a desktop computer equipped with Mr. Kick 3 software. The software was necessary to acquire and save the signals. Then the data was analyzed using the MATLAB software. The fast Fourier transform displayed on the oscilloscope was utilized to estimate the frequencies at which the signal of interest was present. The analog filter was used to empirically determine the corner frequency of the signal and then to manually adjust the corner frequency of a low-pass filter. The corner frequency identified was 1.5 kHz, which was necessary to calculate the sampling frequency of a digital filter. In MATLAB, the signal was digitally filtered using a third-order Butterworth low-pass filter at a sampling frequency of 12 kHz. This initial characterization of the signal acquisition will support the acquisition of data from the FFF model Phantom in the next stages of the project.
To confirm that the UltraBeat wrap does not inadvertently constrict the patient's foot, a force testing setup was developed. An interlinked force-sensitive resistor was placed between the wrap and the skin to assess force values. These relative values will be compared to that of the thumb pressing down on the probe during usual clinical evaluation. As the force on the force-sensitive resistor increases, the voltage value decreases. By comparison of the UltraBeat wrap to the control of a physician pressing on the probe, we will be able to confirm that the UltraBeat wrap does not constrict the patient's foot. Given the opportunity, the UltraBeat wrap will be used on pediatric patients compared to the conventional manual pressure in order to identify if this product helps physicians to accurately and repeatedly measure blood pressure. It is also in our intention for physicians and patients to complete satisfaction surveys to understand their experience with the product. And now here's a walkthrough of how to use the UltraBeat wrap. First, the medical provider should place the UltraBeat wrap around the foot secured with the Velcro. Ultrasound gel should then be applied onto the skin through the opening in the wrap. Next, the ParksMed Doppler ultrasound infant probe should be placed into the probe compartment. Once the flow detector is turned on, the medical provider can assess blood pressure by listening to the ultrasound signal and by tightening the cuff proximal to the artery. Fine-tuning of the probe position may be required to detect the best signal to assess blood pressure. This can be done by slightly moving the probe within the socket and locking it into place once the correct position has been found. You'll be able to say, "Nothing beats the UltraBeat wrap." This project was made possible by the IUPUI Department of Biomedical Engineering and our sponsor, Dr. Adam Keene. We would like to graciously thank Sherry Clemens, Dr. Sharon Miller, Dr. Lester Smith, and Dr. Ken Yoshida for their boundless support. Thank you.